Hi, welcome to my video on tangent chord property number 1. Number 1, prove the angle formed by a tangent and a chord at the point of tangency is half the measure of the intercepted arc on the circle. So to prove this, I have a circle drawn previous to here. So we'll let O be the center of this circle. And we'll draw a tangent touching the circle at one point. So we'll name that tangent B is the point of tangency. And we'll let this point here, so BC is the tangent. And we'll draw a chord BA. So we let this point be A. So what we're given here in this question that we're going to prove, we're given a circle with center O, and we're given that BC is a line, and that line is a tangent. So we can put arrows on the end, or we can just make a segment. We're also given that BA with a bar is a chord, and as a result of this statement, we're given all this information. We have to prove that the angle formed by the tangent, which is BC, and the chord AB is half the intercepted arc AB. So the angle ABC is equal to half of the arc AB. That's what we're going to prove. And to do that, we're going to join the radii of OB and OA. We're going to join those radii. And to make things simple, we're going to let AB, the arc AB, be X, and we're going to let the angle OBA and OBA and angle OAB equal Y. And the reason for that, we have the radii of the circle are equal. So if we let these two angles, since two sides are equal in this triangle, these two angles are equal. So I'm going to let these two angles that are equal be Y each. It just makes it easier to prove without going A, O, B, B, A, O. Using 3 letters, we're going to use just 1 letter for the angle. So to do this proof, we will, or I'm going to write it out partly, that we have this, we're going to let also, we let this arc AB be X. So what happens is that the central angle, this central angle BOA, is also X, because the central angle is the same measure as his arc. So angle AOB is the central angle made of 2 radii with the vertex at the center. So it's half the or it's equal to the intercepted arc. So this arc is X, the central angle is X. That means that we have, I go right here, X plus Y plus 180. So if you add all these angles up, you get 180 in the triangle. So X plus 2Y is 180. So Y equals 180 minus X. Divide by 2, Y equals 90 minus a half X. So what we have is, we have that also, that there's a perpendicular here. This is a radius, and the point of tangency forms a 90-degree angle. So that means that we have OB is perpendicular to BC, because tangent and a radius forms a 90-degree angle. So that means we have angle OBC equal to 90. And angle OBC is equal to Y plus angle ABC. So OBC is equal to 90 degrees, so that's 90. Y plus ABC, angle ABC. But again, from here, 90. So Y is equal to 90 minus a half x, so 90 minus a half x plus angle ABC. So I replace Y with 90 minus a half x. The 90's cancel out, so I get 0 equals negative a half x plus angle ABC. Move the negative to the left side, make it positive, so a half x equals angle ABC. But x is equal to arc, so that's a x is the measure of the arc ABC. So x is the arc ABC by substitution. So we have the angle ABC, half of the intercepted arc. So just a little proof. So this angle formed by the tangent and the chord. So the arc that this angle cuts off, this angle is half this intercepted arc. We're going to use that to do, even though I started out saying tangent chord property, I'm proving this statement first, and I'm going to use this statement to make the tangent chord property a little bit easier to do. So let's do number 2. AB is a tangent at A, and the arc ACE is 240. So 240 is this arc right here. So that means if you take the 360 all the way around the circle and subtract 240, you'll get 120. So that means the arc EA is 120. So if this arc is 120, the angle EAB is half the arc EA, because the angle formed by the tangent and the chord is half the intercepted arc. This is the arc. So that means that it's a half the arc EA, make that an arc, is 120. So that means this angle EAB is 60 degrees. Again, the angle formed by the tangent and the chord is half the intercepted arc. Okay, let's continue with a couple of more questions to do. Number 3, O is the center of the circle. BC is tangent at B, and we have angle A is 25 degrees. It says find the measure of angle ABC. Find this angle here. So we have, that's the center. We have 2 radii is equal. If 2 sides are equal, 2 angles are equal, so the sides opposite those, the angles opposite those equal sides are equal. So if this angle is 25, this angle is 25. Because 2 sides are equal, the angles opposite these 2 sides are equal. So what we have 180 in the triangle minus the 50. So that gives us 100. So this angle at O is 130 degrees. 130 plus 50 is 180. And the central, so that means that the arc AB is equal to 130 degrees. Because the central angle is the same size as the intercepted arc. And that means that the angle ABC is a half of the intercepted arc AB. So that means that this angle ABC formed by the tangent and the chord, there's the chord, there's the tangent. So this angle right here is half this intercepted arc. So AB is 130 degrees. So half of that is 65. And we have one more to do, very similar using this property. We have PE and PF are tangents at E and F. So PE and PF are tangents at E and F. And angle P is 40. It says that VE, this arc right here, is 4x. And the arc VF is x plus 20. And it says find the angle VEF. So we have to find the measure of this angle right here. So let's see, we have two tangents drawn to the circle. So both of these tangents are equal, because two tangents drawn to a circle from a common point are equal. Because these two are equal, that means this angle right here and this one are equal. So if I name this angle as y, name this angle as y, so we have y plus 40 is 180 in the triangle. So 2y is equal to 180 minus 40. 2y is 140. So y is 70 degrees. So we have a 70 here and a 70 here. Okay. Because we have a 70 here, this is a tangent and this is a chord. So that means that because both of these are equal, that means either one of these can be used. So this chord or this tangent, or this chord or this tangent, both of these angles are 70. So this arc is twice that, because these angles are equal. So therefore, either one, twice 70 is 140. So the angle formed by the tangent and the chord is half the intercepted arc. So the arc is BF is 140. That means that 4x add on x plus 20 add on 140 equals 360 degrees. These are degrees here. So all the way around the circle is 360. So we add this up. We add the left side up. Done. 4x plus 1x is 5x. 20 plus 100, 460. So 5x is 360 minus 160. 5x is equal to 200. Divide by 5x is equal to 40. So we have what x is. Now what do we need to find? We need to find a measure of angle VEF. But BEF, let's look at it. BEF is this angle here, but we need to get the arc. So let's get the arc VF is equal to x plus 20. So 40 plus 20, these are degrees, is 60. So the arc VF is 60 degrees. So this angle is a half of the arc VF. So that means it's a half of the 60. So that means this angle is 30 degrees, because it's half the intercepted arc. So again, just some extra properties that we worked out, but the main one is the angle in this video. The main one is that the angle formed by the tangent and the chord at the point of tangency, which is F here, this angle here is half this intercepted arc. I'm going to use that to do the next video to prove the tangent chord property. And again, if you like my video, click on the like button, click on the subscribe button. If you're not a subscriber, visit my math website, www.mathfullyexplained.com, which is just one word, to find more information about me, my video, and the content. That's the content on my YouTube channel called Math Fully Explained. Again, I repeat, it's just one full word, Math Fully Explained. Thank you for viewing my video. Hope the video helped you. Bye-bye.